Okay, so now we're going to start the splitter upgrade project, and I will turn it over to them.
Hi, good morning. We today will present the splitter upgrade, and me and my friend, my name is Mohammed Bashik. And let's begin with the background for this machine. I tried to find who's found this the first machine, but I didn't have the luck to find it. But I know it started since 1607, like before like decade. So I know in America you like people to cut wood. So whatever who invented, you want to make his life easier. So we try to make it easier and safer, more much as we can, and faster. The classic wood splitter is like just go. The basic of it is like go forward and backward and do the slow extension and retraction. And the only safety we need, the only safety the examiner or the engineer expect from this machine, because like it's too dangerous if you want to play with. So the objective, we start with the upgrade the wood splitter and make it a little bit faster. We add the safety measure to know where is the RAM. The position we have 27-inch, so we need to know where is the RAM without we go in the danger area. So we put this feature and we use two hand control. This the goal of the project. We use two hand control and nothing else, and keep the machine do the job. So we put the electric start and we put the magnet breaker for the more safetier. Is something happen, you can push the the e stop button, and it does he full shut down the machine and make everyone safe as much as possible. And the track position for the RAM, we need to know where is the RAM is stop, because we put it for backward or we bring it forward as much as we need. The timeline for this project is take like a long time. We meet 2 to 3 times a week. I'm sorry, we try to remember how many hours we spent, but I'm guaranteed it's more than 34 hours, because we spent too much to make and remake the some of the part of the machine. The let's say this in the beginning and make it clear. This machine actually like since the 80s, and I believe no one touches since that. And when we have the machine, and my friend showed me the machine, like I didn't believe we make it true, but we put hard time, we work on it, we plan it, and we see what we need in each part, how we need to make it or remake it or buy it. The Thanks God the casket company donate a lot of stuff for us, and we will show it in the cost slide. And we make it through. Each time we work on it, we make something new, or we remake something from the beginning, or buy it. We try to manage this time, and we made it finally. Since actually we start working in April 21. From April 21 from like I'm sorry, March 21 to April 21, we work like for the whole 2 months to remake and make, and we do a lot of electric and mechanical stuff to make this happen and work. We're talking about the cost. Actually, this I don't recommend it to do it, but your own money, because a lot of part is too much expensive. We have a lot of donate, and thanks for that. For the Casco company donate a lot of part, and we pay some of the part, but it's not the much they donate. So it's actually in on them, and we thank them and we appreciate that. It's like a little bit of math when we do the math, and it's over $21,000. And I hope we find one day we can make it cheaper and make it for like every house in America, or each house want to buy this kind of machine to make it like working in his house, because it's awesome. Come on, guys. And right now we will go with the risk with my friend Andrew, and he will explain this slide with you. Thank
Thank you, Mohammed. As Mohammed was saying, some of the risks we uh, plotted out ahead of time before attempting any of the project, um, and then some of the risks that didn't happen. So, first thing, we we met the first Sunday after the first class, and to make sure that the motor was going to run. Well, it didn't. We couldn't get it to start, so we had to buy a new motor, which was probably due to some electrical issues we were thinking. It wasn't getting spark, so that was our big first step. Some of the other things that we thought might happen were the main hydraulic cylinder would leak or be seized up or something because it hadn't been run in a while. But that did not take place. So we did not have to get a new cylinder. So as Mohammed said, our goal was to make it safer and upgrade it. So the way we did that was add 2 1-gallon hydraulic accumulators for the forward extension of the ram and retraction of the ram. We added an HMI, a Panel View 7 Plus, to take input from the operator, a PLC to control the servo valve and interpret the input from the operator. The ram was fitted with a encoder so we could track position, as well as a magnetic brake for safety. I'm going to pass it back to Mohammed for these next couple of slides.
Yeah, we're back again. For the BLC, we use the BLC, the SLC 505. So there are a couple of cards I want to explain here. I'll show you what we use for the digital input card. We use it for the different input in the machine. And I want to talk about the last 2 because the analog card, we use it for the valve control. Because we want to know where is the speed for the hydraulic, how much, and we can control it as much as we can. And the high speed counter for the encoder, like what I explained in the beginning, we need to know the position of the ram and how much he go from the 27 inches. So one of the features is hooked up with the HMI, with the BLC, the HMI. The HMI is like we make it simple and we try to make him cover everything we need to do without to go in the front or in the dangerous area. So we can control with the 2-way manual or auto. The auto, what you set up the setting and keep it doing the same job. But the manual here is like you can go inside, you can find the position, find the pressure and the speed, and if the charge or not, and you have the start motor and stop motor, and the important things you have shut down button, like it mean shut down the power from the whole machine to make sure everything is work and is the safe. After that, you can check what happened and start it again. So we play with the HMI, the 17-inch big screen, and we put all this feature to make sure that each one, each examiner or the engineer or the person, let's say it like that, he stand away from the wood splitter or where the dangerous area happen, and he make sure don't go there until he stop the machine and make everyone around safe and take the wood and put it in the fire if you want. We go back with the Andrew to explain the wiring for you guys.
All right, so being a wood splitter, it's portable. We had to have a way to maintain the battery. That is where the starter generator came in. This will generate, it runs off the motor. So once the motor is running, it continuously charges the battery. It goes up to a 12-volt regulator, so we get constant voltage on the battery. It also offers the feature of starting the motor. So as long as the battery's charged, through the HMI, we can do electric start. That's what the motor stop and start buttons were on the HMI. The encoder, so this was a little bit of a doozy for us. We struggled with the implementation of this a little bit. We went through a few different revisions. First thing we thought, we'd just be able to read these pulses in to a counter and count them just like a normal input card. Well, that wasn't fast enough. So then we went to the second option. We had a fast DC sync card, and that still wasn't fast enough. We finally discovered the high-speed counter card, and we hooked it up, and we weren't getting any kind of reading on it. I wonder what the issue is. The encoder sinks current, so we needed a pull-up resistor in order to get a pulse out of the encoder. That allowed the high-speed counter card to count the pulses, and we could see it then. So there's a little bit of setup that goes into these cards. You have to choose what you're going to do. So kind of your input type. We chose pulse and direction with external control because we reset it with a limit switch. Once it returns home, the limit switch gets pressed and resets the count. There's a couple different counter types you can choose. We wanted a linear count, so it just counts up from 0. The counter state, there's pulse and a rate. The rate is measured in a frequency. We weren't looking for that. We wanted to count pulses. And then there's output control, hard or soft outputs. So you can have outputs that just turn bits on in your register, or you can have physical outputs on the card that you have to read in through a different card for control. Then the operation mode, range and rate mode. Range mode offers you, I think it's 12 different ranges. So if you get, you set up ranges of pulses that will trigger the outputs. We had a lot of issues with the outputs due to a damaged card that we received first. So we spent a few hours troubleshooting that, only to realize there was some broken components on it. We then sourced another one through eBay, and that one seemed to work just fine. So here's kind of a block diagram of the card and your choices. So you have your input. Depending on the type of encoder you want to do, we chose the rotary encoder. We only used the A input because the encoder we chose was a one from Amazon, only offering one input. Then we wanted to count pulses, so we did the pulse counter and in range mode. So to set this up was, we had to configure a register. This register we set using bits to count up from 0 to 100 or 1,280. We set 6 different ranges. So we had a soft start, then we went full bore, and then a slowdown. Then on retraction, soft retract, full bore, soft end, which then reset with the limit switch. These ranges allowed for maybe some slack in the count of the card, so we could, once it entered a certain range, that would set the valve to a certain percentage for the speed. So that way, if the encoder the count wasn't quite right, it offered some lacks in that area. So the way we did this in the code was, or the way they recommended it in the data sheet, we followed their recommendation and we created a binary file, and then we copied that file into the location where the registers were in the PLC on startup. Come to find out, there's a nice little GUI that you can just right-click, configure, and change all the settings in. So that would have been, but we didn't find that out till after we did all this. So I'm now going to turn it over to Andrew to talk about the analog inputs.
Good morning. My name's Andrew Dretz, and I'm going over our analog output card. It's actually a combination card. It does inputs and outputs. You have to configure the card to do voltage and set up your voltage range. And it is plus or minus 10 volts. And then you have to load the card with an integer value of plus or minus 32,676. And that's a difficult number to keep track of. So we did a scale of parameters to actually range that value based off of a percentage. And therefore it was easier to keep track of our output. And then we're also checking back through the other input what we're commanding of the valve. So that way at all times we know how much we're asking the valve to move. And then the valve itself has a feedback position sensor on the spool. Now the valve itself is controlled by plus or minus 10 volts that it gets from the card, and the internal card is supplied with 24 volts through another set of pins, and then the spool is actually pulse width modulated to then shift the master back and forth to then divert pressure and fluid to either side of the slave valve. This allows us to have continuously variable speed and position, and also allows the ranges that Andrew explained to allow us to have that precise speed up and slow down control. So as Mohammed said, we have the classic splitter. It's fairly slow, just relies on the pump to supply continuous fluid to move the ram. And then this is our hydraulic schematic to try and get a little bit more out of that. So we're using the same hydraulic pump as originally, but we're charging accumulators to make up the difference in fluid. We are then putting it through the servo valve to control direction and speed. And how the accumulators work is it has a bladder inside of it charged with nitrogen to keep constant pressure on the fluid that is added to it. And then as you demand it, it keeps the system pressure constant and allows the ram to move continuously. Now we ended up going with 2 1-gallons because our math shows that it would use 0.82 gallons to extend and 0.61 gallons to retract. And there's our working splitter. Any questions?
All right, good job, guys. Yeah, so I've got a laundry basket full of questions yet again. No surprise here. So my first, I'm just kind of picturing this thing because we've had professors in the past who have had wood burning implements and so forth. Professor Jewett used to actually hire students to come and split wood for him. So I wasn't quite clear. And speaking for Professor Jewett here, I'm not even sure if he's watching, but if he is, the question that he would probably ask is, you said that this thing totally self-powered? I guess I didn't quite get that. So this thing powers the HMI so you could be remotely in the woods somewhere. Is that true?
So the question was is whether it could run completely isolated, and that is correct in that the generator supplies power to a 12-volt battery on board, and then we're converting it inside the panel to 24 volts to run the HMI. We're also converting it to 120 volts for the PLC, and then we're also converting it again to 96 volts to drive the brake. So,
okay, great. That answers it then. So, and you said also it had electric start. Is there a chance to pull start it if your battery is dead?
that is also an option. The question was if you could pull start it, and what we ended up doing is off the front of the engine, put standoffs so that way the starter generator pulley was on the flywheel, and then in front of that was your normal pull start.
Okay, and this is probably more toward Mr. Reefer. You mentioned the pulses. You had to go to a high speed card. So what kind of frequency are we talking here?
Ooh, that's a good question. So the question was, what kind of frequency does the encoder output? And it is 100 pulses per revolution. Now we have to extend 27 inches, and it was a 6 millimeter gear on the track. So one full extension and retraction took 1,280 pulses. So we broke our ranges down into increments of 50 for the slow down and the speed up ranges, and then in the middle, we were 100% open on the valve.
Okay, and on the encoder again, you mentioned that you're only taking a single output from the encoder. On your diagram, it showed an A and B, and you said you were only using A. So does that imply that the encoder is a quadrature encoder, and you were using only one of the two? Therefore, you didn't know the direction, but you only knew how far. Is that accurate?
Yeah. The question was, do we know, or is the encoder set up as a quadrature so we know direction, or just the one? And yes, that is true. We're only using the one input, so we only count up. But we figured it out to break the ranges up so we know when it's in retracting, it's still counting up, but we know where it's at still, only in the one direction. It kind of makes the ranges a little bit complicated because the number only increases, but it is coming back. So yes, you are correct in saying that.
That's what I thought. And one final question, then maybe Mohammed could answer this one. Is there going to be a Bluetooth version of this coming out soon?
I wish. Yeah, I wish. Why not? If you get Bluetooth, I will stay inside the home, and the snow is outside. Like, yeah, it will be a good feature. Like, next time I will think about that. But thank you for your question.
I want to make sure that I understand it correctly. You have a manual and an auto mode. So when it's in auto mode, it's just going to run.
The question was, what is the difference between the two modes? Yes, the auto mode has preset values. So the speed, the first we go 20%, then or 80%, then 100%, then 80% again on the slowdown. 80% is the minimum amount it takes for the RAM to start moving. Then the manual mode is more, you can change those values as well as direction. Say, you're extending and you get stuck at the end for some reason, you can, okay, I want to reverse, and then reverse it at a speed that you set. It still requires the two-hand, the OptiTouch sensors to be pressed for the arm to move at all times, no matter what mode you're in. So yeah.
That was going to be where my question leads next, because I was curious if it's auto mode and just running, what's your safety features? Because I was thinking, is there a sensor to sense if somebody's in the way putting the log there or something like that?
Yes. Nope. The OptiTouch sensors have to be pressed at all times for the RAM to move. Otherwise, it is stationary.
Okay, I guess I get to finish out the questions here. And they always seem to be related to project management. And there's some criteria we use to determine whether a project is a successful project or not. Could you tell me if your project was successful and what criteria it met to be successful?
Well, Steve, do you want to take this one? All right. I have something to say on this. So I just want to say, because I woke up this morning and I was really thinking about day one. So our first class, when we decided we're going to do this project and we wrote that scope statement, okay, we're going to make the classic log splitter faster and safer. And then thinking about where we were last Wednesday at 5 a.m, it was faster and it was safer. I mean, we accomplished the two-hand control that we said from the beginning that we wanted to implement. And we also added the magnetic brake, which I don't think was in the scope statement off the get-go. As well as, if you've seen on the poster board, it is about 2 times faster than what the original was. And I was just really, really impressed and happy thinking that thought that we accomplished exactly what we said we were going to do. With one extra feature, but not too much more and not any less than what was originally planned. So I don't know if you have something else to say about that. All right.
Okay, let me see if I have this right. So you're telling me the only thing of a successful project is to be on scope?
Well, and on budget and on time.
Oh, cool.
So
Oh, I feel a lot better now. Okay.
we're
So
here today with a
your
working
project was a successful project.
Yes.
Okay. And you actually lucked out because your company donated a lot of this equipment, and budget really was probably pretty good, wasn't it?
Yeah, I think I don't know what you total spent, but I spent like a little over $100 on it total. So
Okay. And I know this project could go wild, right? As you guys saw, or as you mentioned, right? Okay. Okay. So, thank you. That was our log splitter, the splitter upgrade. So, we'll basically break for just a little bit, and we'll get the next group ready.